Today we begin a process of finding zero values after we have factored. So you're going to be able to factor to find the zero values of an equation. And the real reason for why we're finding zero values is because, oh, you're kidding me. Sorry, this is ridiculous. So finding zero values is important because it kind of tells us where things break even. So if we're a business that tries to make money, we're going to find when we start to make some profits. And we can kind of do some things like that after this lesson today. So here we go. The whole point of factoring a trinomial is to try to get it back into two binomials. So we've already factored and we've got it set up into x plus 7 and x minus 2 equaling 0. So it's our job, our goal to try to find x values that would make a 0. This seems kind of obvious, but I'm going to take the x plus 7 and set it equal to 0 because that's going to help me find the x value. When I add 7, it will make 0. Now, right now, I'm going to ask the audience here, what do you add 7 to make 0? Subtract 7 on both sides, and x is going to be equal -7. Because guess what? If you do -7 plus 7, that makes 0. And 0 times, no matter what that is, makes a 0 pair. Okay? So there's the new part of today. It's actually quite easy. Over here, we have to find the other x value that does this. And so all we would do is simply add 2 to both sides and get x equaling 2. Because once again, if I take 2 and I subtract 2, this makes 0. And so whatever this number is, regardless of what x is, 0 times that will cancel that out and make 0. So we're just trying to make work to do with these ones. So 2x minus 1, 3x plus 4. Just break up the two binomials and say I got 2x minus 1 equaling 0. I can drop the parentheses because I'm setting these up as two equations, and 3x plus 4 equals 0. And so now you're back to middle school math where you're just solving a two-step equation. So I always start with addition or subtraction. I'm going to add 1 to both sides, end up with simply 2x because this makes a 0, that's gone, and 1. Not always going to be whole numbers, but don't be afraid of those. Fractions are our friends. Divide by 2, and we've got a half. All right. Go ahead and try to do 3x plus 4 on your own. And so hopefully you were able to subtract 4, divide by 3, and end up with a mixed number of -1 and 1/3. Or if you wanted to even keep it as the improper fraction, that is totally fine. Decimals work too. Okay? So that's the new part of today. Now we go back and do this with factoring. So it all comes together. All of the most recent lessons that we've been doing, we do them all kind of like at once. So this is kind of like where the tic-tac-toe Jamboard came in, where it was really important that you know what process to do. So if you haven't done that lesson from the Friday before break, very important to go back and do that one before you maybe get into the practice on this one. So here we go with factoring a trinomial. And the important thing is, which method would we use? All right, so because there is just a 1 in front of x squared, this is the easy way to factor a trinomial, where we have to add to the b term. The letters don't change. It's still a, b, and c. So I'm adding to +4, but I'm going to multiply to -12, okay? And the reason is that a times c is simply 1 times -12, so that's not going to change. So now I have to make a quick factor list of 12. 1 and 12, 2 and 6, 3 and 4. And here's where your calculator can help you out if you had trouble coming up with the factor list. Now, out of those pairs, which one can we turn into +4 when we add them? Good. Yeah, 2 and 6. Good. 1 and 12 is not going to do it. 3 and 4 is not going to do it. So 2 there, 6 there, and then I do say add, but when we make signs, when we get to choose positive and negative, sometimes we're going to have to subtract. So negative when we multiply, positive when we add them. Going to make it -2. Big number gets the same sign as the sum, +6. So we've got our pair, we've got our numbers, so let's go ahead and put them together as two binomials. So we're going to have x minus 2, x plus 6, and the new thing is it's equal to 0. We're going to take this piece and bring it down. We have not done that. Little minor equations x minus 2 equals 0. X plus 6 equals 0. Who wants a shortcut? All right, so you ready? The thing that your teachers never told you as middle schoolers. You don't have to show this step. Why would you? What are you going to do to move the negative 2? You're going to add it. So what's it going to be on the other side? Positive 2. Bam. Done. What are you going to do to plus 6 to move it? So what's it going to be on the other side? You don't have to do that step. Why would you? You know what it's going to be. You're in 9th grade now. You guys can handle that. Okay? So there it is. You have just found the two zero values for that particular equation. And again, I can bring more real life aspects into this if I had more time, if we had a longer class, if we had a normal school year. But we need to know the process so that if you get to Algebra 2 trigonometry, we can use that. All right, next one. It's only a binomial. So factoring trinomial, don't even think about it. So we got to go with the GCF factoring, okay? So that's where we try to figure out what they have in common, and then we take out that GCF. So break it up into two pieces. What number can go into 2 and 14? Don't think anything bigger than 2. So it's got to be 2, right? So nothing bigger than 2 can go into 2, so your options are 1 and 2, so it is 2. And then x squared, 2 x's with 1x. Do they have at least 1 in common? They got at least 1 there. So GCF is, in fact, 2x. So we're going to take that part out. So let's divide it out. Because if I'm doing distribution, that's multiplying. So to figure out what goes here, I got to work backwards, work oppositely. And 2 divided by 2, you got 1. And then x squared over x to the first. We got 2 x's up top, 1 down low. Leaves us with an x. You kind of think like, man, I feel like we by 2 is negative 7. X to the first over x to the first, 1 minus 1. You get 0 x's left, which means they're gone. All right? So the only new thing today is now it's equal to 0, and you've got one more step. And you do have to break this up into 2 parts. So, this GCF doesn't really have to be here. So what we're going to do is take the 2x, this piece, say that 2x is equal to 0, and do this as x minus 7 equals 0. I think that everyone's pretty excited about the shortcut here, so let's talk about it. If you're going to have to move subtracting 7, how are you going to move it? You're going to add it. So on the other side, it's positive 7. Over here, you're not adding or subtracting. It's multiplied, so you divide. But what's 0 divided by 2? Still 0. All right, so maybe something you could have done in your head. Okay? So we got another binomial, x squared minus 25. And you're probably thinking GCF, which is always good to think first. But the only number here is 1, and definitely no variable in both of them. So you're like, how do you factor this if it's not a trinomial? Well, you can factor it into 2 binomials because it's the difference of 2 perfect squares. Remember that? Where we thought about the one number that can make 25. Anybody? 5, right? So we put that second because it's second in our problem. Whatever the order is, if it's variable, then number, then do variable, then number. If it's number, then variables, then switch them up. All right, we got 2 x's here, so let's put 1x there and 1x there. And who remembers the secret to these? The signs have to be different. It's called the difference of 2 squares because one's positive, one's negative, one's adding, one's subtracting. There's different signs. And then guess what? It's the last step of just making them equal to 0. So I'm telling you that you can skip the equation step, but you can't skip that one. You at least have to show the setup. And then from there, we know that this is going to be subtracting 5. So that's going to be minus 5 on this side. We know that this is going to be adding 5. So this is going to be plus 5 on that side. And that's it. Hopefully your factoring is getting much stronger by doing all of this review. Save the best for last. With total sarcasm. Factoring by grouping. The one that we did on Monday. So had a little trouble with the lesson on Monday. Here's another chance to recap that. So here we go. with labeling them A, B, and C. Because the A value is bigger than 1, we can't use the X, we can't use the easy way. What am I talking about? We can't do it like this, okay? Because it's got a number in front of X squared that's bigger than 1. So I have to take the A and the C term and multiply them. So that is 2 times negative 12, and 2 times negative 12 is negative 24. I'm going to show you real quick how to make factors in your calculator, just in case. So go to y equals, boop, and enter 24 divided by the variable key. And doing that, we'll divide 24 by every x value. Thank you, calculator. I do appreciate the help. So every x value, 24 divided by 0, by 1, by 2, by 3, by 4, by 5, by 6, here's all the answers. It even gives you the ones that end in decimals. But we really care about the one that adds to the b term, which is 5. So looking at our list, which I'm not going to write down, how can we make 5, 1 and 24, 2 and 12, 3 and 8, yeah, just double check, 4 and 6, nah, 6 and 4. So that's all of them. So it's going to have to be 5 and 8. So it's 5 with 8. It's a negative 24. So we know that these signs are different. The sum is positive. So the bigger number gets the positive, the smaller number, what did I write down? 3. 3 and 8. The smaller number is the negative. Thank you, Maurice. You're gonna catch me there. I do make mistakes. Please correct me. All right, so these are the two values I want to use. 2x squared doesn't change. Instead of 5x, I need to write this as 4 pieces. So let's go minus 3x plus 8x minus 12, okay? And then let's continue to write this plus 0. So if you're wondering what we did, we went from 3 pieces to 4. The whole point of that is so that we can now group these into 2 binomials. Because that's what we're trying to get to. We're trying to get to 2 binomials. But this is multiplying. This is still adding, so we're not quite there yet. But now we use our GCF skills, right? What is the greatest common factor of this first binomial? 1 and a x. They both have an x in common, right? So good recognition that it's just 1x. What's the greatest common factor of 8x minus 12? 4 is the biggest number going in the both. So a lot of these are pretty easy and pretty low. So let's rewrite these as 1x times whatever's left after we divide both pieces goes in the parentheses. So 2 divided by 1, still 2. 2x's divided by x, there's 1x left. Got to do it all over again for this right here. Negative 3 divided by 1, negative 3. This x with this x, whoop, they're gone. So there it is, 2x minus 3. Now, what do we definitely know is going to happen? This binomial is going to be the same as this one. All right, let's hope. So I'm pulling out a 4, a positive 4. 8x divided by 4. Ooh, that looks good. 12 divided by 4. 3, right? And we look like we're in business because, let me use my highlighter. Why aren't my tools working today? What the heck? I don't have a highlighter, sorry. This binomial here, this binomial here are the same. So that goes in maybe the first one or the second one, doesn't matter. But then I can take this piece and put those back together. So x plus 4. Well, just when you thought you were done, because on Monday we were done, we're not quite done. It's still equal to 0. It's still equal to 0. So I need to go a little bit further. So because we have 2 binomials now, we can say that x plus 4 is equal to 0 and 2x minus 3 is equal to 0. Easy side first is simply going to subtract the 4. It's minus 4. I've only got 20 seconds left, so I got to go a little faster here. Sorry about the people in class and online. Add 3. 2x equal to 3. Divide by 2. And x equals 3 out of 2. And there you have it, your 2x values. that would make zeros.